exterior angles. Just to review, we learned yesterday. You almost got me again. We learned on Friday that the sum of all the interior angles, the angles on the inside of a shape, are always going to be n minus 2 times 180. That gives you the total inside. But there are also angles that are outside of a shape. These angles that I've numbered, like angle 1, 2, 3, and 4, those are called exterior angles of this particular polygon. What kind of shape did I happen to pick right now? That's a pentagon. But this would be the same thing if it was a hexagon, octagon, whatever. Exterior angles. Now here's why it's so simple. When we were dealing with interior angles, we had this whole formula, n minus 2 times 180. The sum of all the exterior angles never changes. It doesn't matter how many sides there are. What's going to be the sum of all the exterior angles every single time? 360. Boom. That's it. That's going to simplify every problem involving exterior angles because it will wind up involving 360. So look at example 1. Find the measure of one exterior angle of a regular hexagon. There's that key word again. One angle. Remember what I was telling you at the beginning of class. Anytime they're talking about one angle, I want you to think, okay, I get one angle by doing the total degrees divided by the number of sides. That's going to give me one angle. So let's just write that down on our paper to help us remember. So everybody write this down with me right now. Oh, wrong thing. The total degrees divided by the number of sides should equal one angle. Okay, but this time we're dealing with exterior angles. So, Solimar, can you tell me about the total degrees? If we're talking about exterior angles, do you know what the total degrees are going to be?
For the outside?
Mm-hmm.
For the inside?
The outside. 360. Okay? The outside angles, the total degrees will just be 360. So instead of having to put some formula up there, I just get to put 360. Plain and simple. Okay? Mr. Diggs, what's our expression for the number of sides? Ha! Jordan, what do we use to represent the number of sides? N. So I'm just going to put N down there. Okay? And I'm supposed to find one angle. Okay? Oh, wait, it told me that we got a regular hexagon. So what am I going to put instead of putting N?
Come on, Mr. Bird. I felt all confident.
So that's going to be 6. Now, you gave me the right answer to the question I asked you. So what will be the measure of one angle then?
60.
Yeah, that's just going to give me 60. 60 degrees. Okay, pretty simple. Now, each exterior angle of a polygon is 40 degrees. Let's do that same thing again. Okay, I'm still doing the total divided by the number of sides is equal to one angle. Okay? But this time I'm given one exterior angle is 40 degrees. Each exterior angle is 40 degrees. So that means, let's see, Maya, what am I going to put for total degrees? I'm just going to have 360 over n equals 40. Okay? Because that's the total degrees divided by the number of sides, which we don't know, is equal to 40, because that's one angle, which we were given. Okay? Then it's just a matter of solving this little equation. Any idea how to solve an equation like this?
Divide out the 3's between 360.
Yeah, that's one way to look at it, okay? And I'm going to basically say the same thing as you. There's two ways to think about this problem. Have you guys learned about cross-multiplying? Does that ring a bell? Yes. If I put this as like 40 over 1, for example, you know what? That one way to look at it is you could think of it as a cross-multiplying problem. Okay? Or, anytime we want to get rid of something that's in the denominator, can't we just multiply by it? Oh, which is basically what Daniel was saying. So since I have n in the denominator, I could just multiply both sides by n, couldn't I?
Yes.
So that's going to cancel out those n's. So that leaves me 360 is equal to 40n, yes?
Yes.
So what's the last step?
Divide.
Yeah, just divide. This is what Daniel was saying. Divide everything by 40. Okay? So what is that going to be, you guys? 9. Okay, so this thing had 9 sides. So that's a lot simpler than for interior angles when we have to do the whole n minus 2 times 180 and we have to distribute. This time it's just 360. Much simpler. Okay, but keep it straight. We do 360 when it's exterior, the outside. When it's the inside, we have to do the whole n minus 2 times 180 thing. Okay, look at example 3. The measures of the exterior angles of a hexagon are given. Find the value of x. Can I get a volunteer to tell me how I will approach this problem? Any ideas, Prothero?
Would you add up all of the numbers without x, and then once you find that total, you would subtract that from 360 to like figure out then what like you would divide by to get x.
Right, this is a hexagon. So how many angles are there?
There's 6 on each side.
6. All right, hexagon should be 6 angles. How many little expressions are we given? Okay, we got 6 angles. We're given expressions for all 6. Prothero, what should they add up to be?
360.
They should add up to be 360. So what I hear you saying is, basically, you know, and you don't have to write this part down, but if we took 90 plus 60 plus 4x plus x plus 30 plus 2x, you don't have to write all that down. But if we added all those up, it better add up to 360 because we're talking about exterior angles, and they always add up to 360. Okay? But Isabel was talking about basically combining like terms. So look at the x's. I have 4x and 2x. Put those together, what do you got? 7x. That gives me 7x. And then look at all these others. 90 plus 60 plus 30, 180. Yeah. 7x plus 180 equals 360. Okay? And the rest is easy, yes? What's going to happen next? Subtract 180. Yep. So that's going to give me 7x equals what? 180. Last step? Divide by 7. X equals 25.7, so we have to round. X equals 25.7 approximately. Okay? You guys get the idea? All right, any questions so far? All right, so it's time for me to pause the talking at you.